Hello again. Section 7, we are interested in discussing the synthetic strategies for making amines that might have 1, 2, 3, up to 4 different alkyl groups, or maybe 2 the same and 2 different, and there's different strategies for doing this. I think this map here kind of highlights the basics of everything all on one slide. This is a figure from the textbook, and we can see that the Gabriel synthesis, the azide synthesis, and reductive amination can all create a primary amine, and this R group could be one of your choosing, okay? It could be a methyl, a phenyl group, whatever, okay? Now you can do this a second time to introduce a different, or the same if you wanted to, alkyl group, okay? So this could be symmetrical or unsymmetrical as you see fit. The third reductive amination, for example, could install a third alkyl group to synthesize an unsymmetrical tertiary amine. And then you could alkylate this in any way you want, typically with an alkyl halide, to give you a quaternary ammonium salt. So that would be potentially a nitrogen atom with up to 4 different alkyl groups surrounding the central nitrogen atom. And we'll go ahead and the book doesn't really go into a lot. It gives you a sample problem and just has you go at it, okay? So we're going to go at it by doing some sample problems. There's problem 18, which looks pretty good. So let's get started. All right, here we are. So we're going to use ammonia as my only source of nitrogen, and I'm going to show the reagents I would use to prepare each of the following amines, okay? So we want to take this molecule and just, choose a side. They look like they're both primary carbons here. This carbon is attached to 1 additional carbon. This carbon is attached to 1 additional carbon. So I'm going to disconnect there, okay? So that molecule right there could possibly come from an aldehyde. Let's draw the aldehyde. And it could come from ethylamine. Let's draw ethylamine. Okay? All right, good so far. Now, ethylamine, so let's stop right there for this molecule. Ethylamine is not ammonia. So how are we going to synthesize that from ammonia? We're going to do a similar disconnection right here. And I can see how that can come from ammonia. Let's stop there, that's ammonia. And that can come from acetaldehyde, okay? 2 carbons with an aldehyde is acetaldehyde, so let's start there. So 1, 2, 3, these are our 3 starting materials to synthesize this rather complicated, I'm missing a methyl group, this complicated product. Okay, so this is the disconnection approach to synthesis, okay? We want to divide the molecule into smaller bits and pieces that are very cheap to buy, and then you, with your intelligence, go and do these reactions and make this amine that some pharmaceutical company is willing to pay, much more money for, okay? That's the idea. We want to make some money. So the first step we want to do is we're going to do this reaction here. So let's start off with acetaldehyde. We're going to add ammonia, okay, H+, Na, BH3CN, and that's going to make my ethylamine. Boom, got it. Now I want to do this second reaction. I'm going to take that amine. I'm going to add, it doesn't matter what we put above the arrow. We can put the amine above the arrow and the aldehyde to the left, or we can do it the other way around. And this is the other way around. I hope it does not bother anybody. So we're going to add this aldehyde here along with this amine, stirring in the same flask or whatever. H+ catalyst, NaBH3CN, and we're going to make this highly complicated molecule of interest. Okay, so that's the basics. That's the idea. Let's do some more practice. All right. Part B, easy, easy peasy. So what we got to do is just chop right here. Immediately we get ammonia and we get a ketone on that carbon, and you were done. So this is going to be a one-step simple reaction. We're going to start with cyclopentanone. We're going to crank up the heat, add some ammonia, H+, NaBH3, CN, and we're going to get the primary amine there, okay? Cyclopentylamine. We're done. Let's do part C on the next page because it looks more complicated, doesn't it? All right, part C is kind of a little complicated because you have 3 bonds, a tertiary amine. So we got to do 3 different alkylations. So we want to split this guy up. We could split it down here, right? And that's going to give us cyclopentanone, all right? And my dimethylamine, that's not ammonia. So stop right there. That looks good. That can come from methylamine, okay? And formaldehyde, okay? And then this can come from formaldehyde and ammonia, okay? Yeah, NH3, okay? So how am I going to do this? Well, let's do the synthesis as follows, okay? So we want to take formaldehyde. We want to treat this with ammonia, H+, NaBH3CN, okay? And that's going to make methylamine, okay? So that single carbon becomes a methyl group. It looks weird when you see it the first time, but then you get more familiar with it and it kind of begins to click. We want to do this reaction again, so let's add formaldehyde again. H+, NaBH3CN, and this is how we make dimethylamine. Okay, so great, we have dimethylamine, and now we can do this last complicated reaction. We can add cyclopentanone to this, H+ catalyst, NaBH3, CN, okay? And that's going to give me the molecule there in part C. Okay, so far so good. That's how you do these problems, okay? Let's do part D now. In part D, we have a secondary amine, so we're going to do 2 reductive aminations. The first disconnect is going to be here, and that can come from acetaldehyde and ethylamine. Ethylamine can come from ammonia and acetaldehyde. So that's great. 2 starting materials can make this one product. So let's get started with the synthesis here. We would want to write out the first reductive amination with acetaldehyde. We're going to add ammonia, which is the only available nitrogen source they're telling us to use. And we're going to get the disodium cyanoborohydride. Technically that has nitrogen in it, but you know what I mean. The ethylamine is produced, and we kind of rinse and repeat. We add more acetaldehyde, H+, sodium cyanoborohydride, and this gives us the molecule there in D, okay? Part E is a tertiary amine, isn't it? So we want to slap this guy and chop it up into 3 pieces. So that's going to come from 3 equivalents of acetaldehyde and ammonia. So hopefully you've seen the other parts, and this part just kind of makes sense. So we're going to start with acetaldehyde. Okay. Add ammonia, H+, NaBH3, CN, and that's going to make ethylamine. We add acetaldehyde, H+, NaBH3, CN, and that's going to make diethylamine. We add acetaldehyde, H+, NaBH3CN, and we get triethylamine. All right, why can't we just add ethyl iodide? Well, if you add ammonia and 3 equivalents of this, you're going to get mono, di, tri, and over alkylation, which gives you the tetra ethyl ammonium bromide. So this gives you an awful mess and a mixture, okay? So don't try to do that. Do the reactive amination, which is very selective. All right, let's do part F. We're almost done. Part F is a very unsymmetrical tertiary amine. So we want to slap an imaginary molecular knife there. And what we're going to get is our ketone on the left and amine on the right with our, nice little groups there, okay? And then we want to keep doing this, okay? So break that bond there. That's going to give us ethylamine and acetone. And ethylamine can come from ammonia and acetaldehyde, which is what we saw before. Now, in case you're wondering, on paper at least, for this homework assignment, you don't need to really concern yourself with which aldehyde or ketone you start with. You could start with cyclopentanone, acetone, or acetaldehyde and work sequentially through all of these reactions to give you the final product. It doesn't make any difference for this case. In reality, you would want to check the toxicity or how easy it is to separate these products, and other considerations would go into the order of reactions. But here, don't worry about it, okay? So with that in mind, I'm just going to start from right to left as I broke it down. We're going to start with acetaldehyde. Add your ammonia, H+, NaBH3CN. That gets the ethylamine. Then I'm going to do the reaction with acetone. Don't forget your H+, NaBH3CN. That gets the isopropyl group on there. Okay, so there's my isopropyl group. And then I want to add cyclopentanone. Okay, H+, NaBH3CN, and that's going to get molecule F. All right, so that's how you do this problem here. There's a couple other 3 or 4 problems in the textbook, and the textbook, as usual, says try problems 50, 51, and 86. So please do some additional practice problems on your own, but this is the basics of it. I hope this video helps you. Thanks for watching, and please do consider subscribing.